Alright, so what we need to know about force. Push or pull acting on an object. Every force is an interaction between an agent and an object. The agent is a physical thing doing the pushing or pulling. The object is a physical thing being pushed or pulled. Any object may, and usually does, have more than one force acting. There are different types of forces. Which type of force acts depends on what the agent is. A force is considered a pull force if the force attracts the object toward the agent. So in this direction, pulling towards. Weight is a pull force because gravity pulls objects towards planets. Tension is a pull force because you can't push something with a rope. It just doesn't work that way. It goes limp on you. Force is considered a push force if the force repels the object away from the agent. A normal force is a perpendicular force. In physics, we use the word normal, which just means perpendicular. Normal force is a push force because normal force pushes away from the surface that exerts it. So if an object is resting on a surface, take my phone, take my eraser, there's a surface force pushing away from the surface. Some forces can either push or pull, like the applied force can be a push or a pull because when we say applied force, we're talking about force from the hands, depending on how we're using our hands. Spring force can be push or pull because springs push or pull depending on if they're compressed or if they're expanded. For some forces, push and pull don't really have meaning. For example, friction and air resistance are hard to say whether or not they push or pull, and we'll see that later. That's why it's useful to just think of friction and air resistance as opposing motion. Think about it that way and you won't go wrong. All forces are measured in units called a newton. A newton is represented with the unit symbol capital N. More newtons, stronger force. Forces are vectors, so they not only have a magnitude, but they also have direction. The magnitude for a force is going to be the strength of the force. The device that measures a force is called either a force sensor or a spring scale. A force sensor or a spring scale measures the force that the sensor or scale exerts. Types of forces. This depends on how the force is applied. We've got weight. Weight is the force that one object exerts on another using gravity. For everything you've ever experienced, the agent of weight force is the Earth. So, for me, the force that Earth exerts on me is my weight. That means that gravity pulls down on me is wrong. Gravity pulls the book down is wrong. The correct statement would be Earth uses gravity to pull me down. So Earth is the agent, not gravity. Gravity is not doing the thing. Earth is doing the thing. The amount of weight an object has depends on the mass of the object and the gravitational field the planet is on. Weight is our mass times the gravitational field that we're in. The basic equation for weight is F sub W equals mg. Again, F sub W measured in newtons, mass measured in kilograms, and this g, we haven't talked about that yet. Gravitational field is determined by the properties of the planet that the object is on. So how heavy the planet is, how big the planet is, the radius. On Earth, g, on average, will be 9.8 newtons per kilogram. This means that every kilogram of your body has 9.8 newtons pulling down on it. If I'm 100 kilograms, my weight is 980 newtons. I'm not 100 kilograms. Perhaps in the future, I'll reach that goal. It's like 220 pounds. I don't want to reach that goal. The actual strength of Earth's gravitational field is 9.8 newtons per kilogram. We often round this to 10 to make our calculations simpler. If we're doing a real-life hands-on activity with real objects, we have to use the real number of 9.8 newtons per kilogram. Anything we do on paper, tests, quizzes, anything like that, use G equals 10 newtons per kilogram unless it's noted. We take time tests, so using 10 is going to save us a keystroke on a calculator to allow us some more time to comprehend some material. Other planets have different gravitational fields. You don't have to memorize these, but here they are. The moon is 1/6 that of the Earth. Mars is 3.7 newtons per kilogram. Jupiter 24.8 newtons per kilogram. Weight is a vector, so near the surface of the planet, weight always points straight down. That's true for us. We're always going to assume weight, the force of our weight is pointing straight down. Because weight attracts the object towards the agent. Remember, the agent is the planet. Weight is a pull force. Of the forces discussed in this lesson, weight is the only force that's not a contact force. Misconception. She says, weight and mass are two words for the same thing. Mr. Wright, sorry for the sexism here, says, no, mass is a property of an object. Weight is a force acting on the object. Weight and mass are directly proportional, meaning that if mass is doubled, weight is also going to be doubled. So even though they feel like the same thing, they sound like the same thing, they are different. They are proportional to each other, but they are different. The equation for AP Physics 1 is going to look like this, where it's G equals Fg over m. Another way to look at G is looking at it as an acceleration. So rather than 9.8 newtons per kilogram, you could think about it as 9.8 meters per second squared. Both of those things do mean the same thing. Be aware of that. But for the gravitational field, to calculate your gravitational field, we're going to divide out our mass from the gravitational force. Pause there.